Hello guys, today we're gonna discuss internal first paper 2. So let's begin. The first question is to write an algorithm for decision tree induction. As you can see, decision tree induction algorithm says the first step is to take input, training data set D with features and corresponding label. So we are given a set of features f equal to f1 to fn. So stopping criteria example maximum depth or minimum samples per leaf. The output would be a decision tree. Procedure is if stopping criteria are met, then we create a leaf node with the majority class or mean value. Then we return the leaf node. If all instances in D have the same class, so create a leaf node with the class label and return the leaf node. Select the best feature Fi for splitting. So the top decision tree is the best feature that starts the splitting. So calculate the information gain or variance reduction for each of those feature. Choose the feature with the highest gain or reduction. Split the dataset into subsets based on selected feature. For each unique value v of the selected feature, create a child node. Re Recursively apply the decision tree induction algorithm to the subset of instances with feature fi that is equal to v. Then attach the resulting subtree to the child node. Return the constructed tree. The current node represents the decision based on selected feature. Each child node represents a possible value of the selected feature. Now we train the decision tree using the training dataset and the algorithm described, and we make predictions by traversing the tree based on the features of new. So we have given a note here that the splitting criteria depends on the task. The stopping criteria prevent overfitting and may include parameters like maximum depth, minimum samples. The pruning techniques can be applied to post-process the tree and improve generalization. This algorithm is a high-level representation and the specific details may vary depending on the implementation and the type of decision tree algorithm. Example ID 3, C4.5, CART. Okay, question 2. What are the attribute selection measures? Explain three of them. So understanding attribute selection measure in decision trees or attribute selection measure is also known as splitting criteria or impurity measures. These are pivotal when using decision tree algorithm to determine the best attribute for data splitting. These measures are used to gauge the effectiveness of an attribute in separating data into distinct classes. Below are the explanation of three commonly used attribute selection measures. The first is information gain. Information gain measure are the reduction in entropy that comes from splitting data based on the particular attribute. Entropy is a concept from information theory that measures the disorder or impurity in a set of data. A set with all instances belonging to the same class has low entropy, while a set with a uniform distribution classes has high entropy. Gini index. This is the second one. Gini index measures the impurity of a set by calculating the probability of misclassifying an instance randomly chosen from the set. It is defined as the sum of squared probabilities of each class subtracted from 1. That is, we subtract all the squared probabilities from 1. Gini index is minimized when set is pure. Variance reduction. Variance reduction is used in regression trees to minimize the variance of the target variable within each subset created by the splitting data. It measures the reduction in variance achieved by splitting the data based on a particular attribute. The goal is to find splits that lead to subsets with lower variance, resulting in one more homogeneous subset. So variance reduction before split minus weighted average for variance. Gini index is 1 minus the summation of all the square. And entropy gain is entropy before split minus weighted average entropy after split. These are the formulas. The third question is define and mathematical expression of information gain, Gini index, and reduction in impurity. So first is information gain. Information gain is the measure used in decision tree algorithm for selecting the attribute that results in the most significant reduction. Mathematical expression is information gain can be written as entropy before split minus weighted average entropy after split, where entropy before split is the entropy of data set before the split, and weighted average entropy after split is the weighted average of entropies of subsets after the split. It is different. In Gini index, uh, it is a measure of impurity used in decision tree. As you can see the formula, Gini index is equal to 1 minus summation of 1 to z pi square. That is the square of the a upon s square, b upon s square, c upon s square. Reduction in impurity is generic term that refers to that decrease in impurity or disorder achieved by splitting the data set. It is written as impurity before split minus weighted average impurity after the split. Question 4. Explain the concept of overfitting and tree pruning. Overfitting, it is a phenomena in machine learning where a model learns the training data too well, capturing noise or random fluctuation in the data rather than the underlying pattern. This can result in a model that performs well on training set but fails to generalize to new unseen data. Overfitting occurs when a model is too complex, capturing the specificities of the training rather than the overall trends. Causes of overfitting. Complexity of the model. Models with too many parameter or feature may fit the training data too closely. Insufficient data. That is, with the small data set, a complex model is more likely to memorize the data. But if the data is too large, so the complex model cannot memorize the data. Noise in the data. If training data contain noise, the model may learn to accommodate them. Effects of overfitting. It is reduced generalization. The model may perform poorly on new unseen data, high variance. The model's prediction are highly sensitive to variations in training data. Tree pruning. Tree pruning, it is a technique that is used to address overfitting in decision trees. Pruning involves removing part of the tree that do not contribute significantly to its predictive power. It helps simplify the tree by removing unnecessary branches, leading to a more general and less complex model. It is less complex. Types of pruning. Pre-pruning, that is early stopping. The tree is stopped from growth before it becomes complex. So we can call it as early stopping. Common stopping criteria include maximum depth, minimum samples per leaf, or a minimum improvement in impurity measure. And the other is post pruning, that is pruning after tree construction. The tree is fully grown and then the branches are removed based on criteria such as impurity reduction or accuracy improvement on a data set. The advantages of pruning decision trees and how to implement it. Enhanced generalization. Prune trees have lower risk of overfitting and often perform better on new data. Reduced complexity. They are simpler and more straightforward. Computational efficiency. Smaller trees use less storage and it can be evaluated more quickly. Pruning procedure, it develop a full tree, create a decision tree without any limitation until it includes all the specifics of the training data, analyze nodes for pruning, prune nodes, and then final prune tree. Analyze nodes for pruning, start at the leaves and assess the impact of extracting a subtree from each node. Prune nodes eliminate subtrees that do not make a substantial difference in predictive performance. Final pruned tree. The end result is a pruned tree that is more generalizable and less prone to overfitting. In summary, overfitting is a typical problem in machine learning, but tree pruning is technique that can help it in decision trees by simplifying the tree structure. Pruning is done by removing unnecessary data, resulting in a more robust and generalized model.